Now here we're going to look at what's called the dot product, and the dot product here is when we're going to actually multiply two vectors together, and we have one vector u, and if we have the components, we'll call those u sub 1 and u sub 2, and v, we'll call that component v sub 1 and v sub 2. And the way that we multiply using this dot product, if we were to take u dot v, then we're simply going to take u1 times v1 plus u2 times v2. Now realize here we're going to end up with numbers, so when we actually add these together, this answer is not going to be a vector. The answer is going to be what we call a scalar. In other words, it's only going to have magnitude. It is not going to have any direction. So here's the formula for your dot product. So if we look at an example, that's u equals 1/8, v is equal to -3, 2, and if we want to look at the dot product, we're going to take u dot v, which means we would have 1/8 multiplied by -3, 2, and just like the formula, we're going to take and multiply your corresponding coordinates. We're going to take u1, v1, so in this case we're going to multiply 1 times -3 plus 8 times 2, so therefore we're going to get a -3 plus 8 times 2, which is 16, and then a -3 plus 16 is simply equal to 13. And once again, notice the answer is a scalar. In other words, we end up with just a number. So when we use the dot product here, your answer is not a vector, it turns out to be a scalar. So keep that in mind when you are using this dot product. So let's try another example. What if we had the vector 1, -4, and then we multiply that by the vector 2, 2, and then we're going to multiply that by -3, 4. So notice here we now have three vectors, and maybe you can try to think about this for a second to see if we multiply this out, is the final answer going to be a vector, or will the final answer be a scalar? Well, we have parentheses, so we're going to start here on the inside. So we want to look at the dot product here. So that means we're going to take 1 times 2. So we would end up with 2. And then -4 and 2 would be -8. Okay. And then we have our vector still out here, which is -3, 4. So 2 plus a -8 would be -6, and we still need to multiply that by the vector. And now probably, hopefully, you're going to see what's going to happen. Once we multiply the two vectors together, this -6 is a scalar, and now we just have a scalar multiplied by a vector. So this is your scalar multiplication we talked about before. So now all we're going to do is distribute the 6, and the answer will turn out to be a vector, because we're going to get -6 times -3, which is a positive 18, and -6 times 4, which is a -24. So notice here, if we multiply three vectors together, your answer turns out to be a vector. And you probably can make a conclusion here. If you multiply an even number of vectors, you will have a scalar, and if you multiply an odd number of vectors, then your answer will be a vector. All right, let's take a look at one more example here. What if we have, let's say, the 0 vector. So this is the 0 vector being multiplied by the vector 2, -5. Now here you want to be careful. could probably rewrite this to see it a little bit better. The zero vector, remember, means that we have 0, 0. Okay, so this is a vector. So don't think you could distribute this and you're going to end up with the vector 0, 0. But when you take the 0 vector, which is the vector 0, 0, and we multiply that by 2, negative 5, remember here, once we multiply, we have two vectors, your answer will be a scalar. And that's because here we're going to get 0 times 2, and we're going to add that to 0 times the negative 5. So that means we're going to end up with 0 plus 0, so therefore the answer is 0, and this answer is not a vector, but it is simply a scalar. Okay, and that goes back to one of the properties. If you take a 0 vector and you multiply that by any vector, then your answer is going to be 0, where that is a scalar and not the 0 vector. Okay, so there's a couple properties with the 0 vector. Let's look at another example here. If I told you that our vector u is equal to 3i plus 4j and v is equal to 7i minus 2j, and if we want to find u dot v. Now it doesn't matter, we can leave it here in this form with, in terms of I and j, this linear combination for the two vectors, but I really prefer to write this as the component form. I just think it's a little bit easier to see. So in other words, 3i plus 4j, we could simply write that as 3 comma 4 multiplied by 7i minus 2j, which is the same thing as 7 comma negative 2. And now we just apply the dot product rule, and that means we have 3 times 7, which is going to be 21 plus 4 times a negative 2, which is a negative 8. So therefore, 21 plus a negative 8, your answer would be equal to 13, which again is a scalar. All right, we have one last example, and you might want to pause the video and see if you can do this on your own. This one here, we have a vector that is 3, 3. We have another vector that is negative 4, positive 2. And this one has a third vector, which is 3, negative 1. And here they want us to find v dot u minus w dot v. So again, maybe stop the video and see if you can figure this out on your own. And before you multiply this out and perform all the calculations, see if you can determine if the answer should be a scalar or if the answer is going to be a vector. All right, so first here we have v, which is negative 4, 2. So in place of v, we're going to write negative 4, 2, and that's going to be multiplied by u, which is 3, 3, minus w, which is 3, negative 1, and v, which is negative 4, 2. So now we're just going to look at this one by one. So here we end up with negative 4 times 3, which is negative 12, plus 2 times 3, which is 6. And then this is going to be minus, over here we're going to end up with 3 times negative 4, which is negative 12, negative 1 and 2 is a negative 2. So if we go back and combine like terms, we have a negative 12 plus 6, which is negative 6, minus negative 12 minus 2 would be a negative 14. But now we have the two negatives, negative 6 minus a negative, so it's negative 6 plus 14, which is equal to 8. And once again, the answer is a scalar. Now, that makes sense that it's a scalar because if we look up here, if we take v dot u right here, this is going to give you a scalar, and then w dot v over here is going to give you a scalar. So we have a scalar minus a scalar, so therefore your answer would simply be a scalar. In other words, we have an answer with only magnitude and there is no direction. Okay, so here hopefully you're familiar now with the dot product. Just keep in mind that when you multiply two vectors together using this dot product, your answer will be a scalar.